Okay, now what we're going to do is we're going to talk about what if they're inconsistent, consistent, or independent, and dependent. Sometimes you don't have to graph them to determine that. Sometimes all you have to do is put them in slope-intercept form. So on number 1, what do we need to, on number 2, what do we need to do? Yep, subtract the 4x. Okay. Now what we're going to do is I'm going to take care of the next one. 3y equals 8 minus 12x. What do I need to do? But we need to flip it, and what else? We need to divide everything by 3. But I am going to flip it because I need that 12x to be in front. So negative 12x divided by 3 is, and then 8 divided by 3 would just be 8/3. And you guys can't see that? There we go. Now, when you look at these, it says if they have if they have the same slopes but different b's. So these have the same slope but different b's. So this is in the little chart that's next to the bottom. Since they have the same slope but different y-intercepts, there's no solution. So I don't even have to graph it. There is no solution. I just want to put this because same slope, different y-intercepts. And that's because they're parallel lines. I want to put as much information here for you as possible so you know why. And because they're parallel lines, they are inconsistent. So again, there's no solution because they're parallel lines. How I know they're parallel lines is because they have the same slope but different y-intercepts. You guys, we will encounter lines that have the same slope and the same y-intercept. That's going to be different. So you really have to pay attention, and putting them in slope-intercept form is the best way. So on number 3, what are we going to do? Put it in slope-intercept form because that's our favorite to do, right? Everything's our favorite. So I'm going to go to my handy dandy other piece of paper. So I'm going to have 9x minus 2y equals 11. I'm going to subtract 9x from both sides. And now what am I going to do? Love that you guys answer me. Hey, 5th period. 1st period answers me. Why can't you guys answer me? Mic down. What is it? No. Drop mic. Oh my God. Oh. Listen, when you're my age, you'll talk about the crazy lady you had for Algebra 2. It's all good. I have to give you something to talk about. I mean, not that I probably don't give you anything to talk about right now. God, that woman. Yeah, I know. It's okay. Okay, so that's the first one. Now we need to fix the second one. So, and what I don't mean fix, but write it in slope-intercept form. So we wrote the first one and slope-intercept form. Now we're going to write the second one. So I have 5x plus 4y equals 13. What do I do now? Put it in slope-intercept. How do I do it? Subtract the 5x. Now what do I do? And remember, you guys, when you say divide by 4, you need to divide everything by 4. So we are looking at this line, and we're looking at this line. The one thing that you have to make sure is that any fraction is reduced, because if it's not reduced, they might look different. So make sure you have everything reduced. So we're looking at these two graphs, these two lines. Do they have the same slope? There you go. You've just answered your question. Because they do not have the same slopes, they are going to be, so slopes are different. Oh my gosh. This is why I should sometime not teach at first period. Slopes are different, so that means they're intersecting lines. Because you guys, as soon as the slopes are different, it means that the lines are intersecting, okay? Same slopes means that the lines are going to be parallel or going to be the same line. And this also means that it's consistent and they're independent. One does not affect the other one. That's what that means. Because so the slopes are different, that means they're intersecting lines and that it's consistent and independent. Okay. So the next one is use substitution or elimination to solve each system of equation. So substitution means you're going to replace a variable in one of the equations. Elimination means you're going to eliminate one of the variables. So there's a couple of thought processes here. It depends on what you like better. When you get to math analysis or trig, or you get to advanced topics, they're going to ask you specifically to solve a certain way. I know that Mrs. Adams, if you go to math analysis next year, she is going to ask you specifically, solve by substitution. Then she's going to ask you to solve by elimination. She's going to ask you to solve by graphing. And then she's going to say you can solve anyway. And if you do not solve by substitution, and she's asked you, she's going to take points off because she wants you to know. I am not like that because I don't always like substitution. I like when substitution is easy. So I'm going to show you the difference between what's a good substitution problem, what's a good elimination problem. So number 4 right here, this is probably an okay substitution problem because there's no number in front of y. Do you see that there's no number in front of this y? So I'm going to rewrite this equation so that the y is by itself. And we already have practiced this, right? It's kind of like putting it in slope-intercept form. So I'm going to subtract the 2x from both sides. Y equals negative 2x plus 7. Now, see what y equals? What does y equal? Y equals negative 2x plus 7. So I'm going to replace y in the top equation. I'm going to leave 5x. I'm going to put that minus. I'm going to put the 3. But instead of y, I'm going to replace y with negative 2x plus 7. So this is what we call substitution. It means we're replacing a variable with a number or expression. Usually we use substitution to check a problem or when we evaluate. This is when we're solving, and don't forget it equals 23. Now we're going to solve it for x. 5x. And we're going to distribute the negative 3. So negative 3 times negative 2, negative 3 times 7. What is negative 3 times negative 2? So it's going to be positive 6x. Negative 3 times positive 7. And then 5x plus 6x is, I'll help you out. Okay, now what am I going to do? I'm going to add the 21 to both sides. What is 21 plus 23? We all agree it's 44? Okay. And then what are we going to do? And what does x equal? That's what x equals. Guess what we have to do now? We have to find y. You guys, whenever you go to find y, don't replace it in your equation. Replace it in the original equation. Okay, so we're going to replace the 4 into the 2x plus y. So 2x, so we're going to replace x with 4, and we're looking for y. So I plugged it into the original equation, the 2x plus y equals 7. I replaced x with 4. 2 times 4 is 8, and then what am I going to do? Subtract 8 from both sides, and y equals negative 1. Our final answer is going to be 4, negative 1. That's our answer. Now, can we make sure that we're correct? Can we make sure that we solved this correctly? We can check it. So let's check it into the original one. What is 5 times 4? 20. Negative 3 times negative 1? So 20 plus 3 is 23. We know it works for the bottom one because we just found it. So this is our answer. Okay. I just think that's enough today. Okay.